Good afternoon, everybody. Thanks for being here. I'm so glad for the opportunity to present a little bit of this research that we have been doing. A little bit of my background. I'm originally from Brazil. I got my bachelor degree at the University of São Paulo. And then in 2016, I moved to Florida to pursue my master's degree at the University of Florida, working in potato production. And then last year, I came to know about this project and this soil health initiative, and I got very interested about it because of two main components. The first one is this opportunity to work with producers, with extension personnel. And the second aspect is this system level approach. We are working with producers who are dealing with like multiple things at the same time. So we are not looking at a single management practice, but how all these different management practices, what you are trying on your field, how can we bring some information that is valuable for making decisions? So I got very interested about this project, and I was like, okay, let's move from Florida. It's too warm here. Let's go to Nebraska. So that's like how I started last year, and I'm going to present a little bit of what we have been doing. So when we look at this soil health initiative, I like to approach it like in three different perspectives. The first one is the experiential learning. So our producers, like and all the other producers part of the on-farm research, they are testing management practices on their own field. So this is good because you are trying different management practices where those would probably be implemented, right? So you can see on your own field what is going on. The second aspect I like to mention is the technical one. So when we started work on this project, we are trying to bring some data analysis, how we can combine all this together and provide you some valuable information on what we have been collecting. And the third aspect is the social one, like what we are doing here today, sharing our experiences, what we have been learning. So this is great, and this is like the social part that I like to mention. So for my presentation today, I'll focus more on this technical part, showing you some of the data that was already collected and some information that we can provide to you. So the first one is what properties should we look at when we are talking about soil health and how to sample our soils, right? So when we talk about soil health, we have the physical, the chemical, and the biological properties that Dr. Dreiber already mentioned before. So we decided to collect some of those measurements on 4 of those fields working with us. Those fields have cover crop and no cover crop strips. So the reason we selected those fields because that's where we are expecting to see like the highest difference in terms of management impacting the soil health. And one thing that we decided to do is not only collect samples on the area where the farmers are testing those, but also on a reference condition that we selected. This reference condition is either a native or a naturalized vegetation nearby the producer area. So this helps us to frame our soil health metrics in terms of conditions relatively to a soil capacity. So we were like, this reference condition is the maximum, let's say, capacity of that soil from that area where the experiment has been conducted. The majority said chemical, right? So that's what actually happened in real life. You select a lot of fertility or chemical measurements to assess the soil health on your field, a little bit on the physical one, and the biological, like we could see in the survey, almost never or like it's barely assessed. So for those 4 fields, we selected those soil properties to look at the soil health of those fields. Like I said, there were 4 fields, but let's look at those 2 ones, one from Colfax County and one from Merritt County. These are the plot layouts, and I wanted to think about, look at a single strip, treatment strip, And what is something that call your attention when you look at a single treatment strip on the field? So look at all these different numbers here. It means different soil types. So you see, like in a single strip, treatment strip, we have 3 different soil types. So how can we sample those fields? If I'm comparing cover crop versus no cover crop, how do I sample? So those soil types are quite different, and they they are different soil types. So for example, here we have 3 soil types, different percentage of sand, silt, and clay. The same here. So here is a more sandy soil, but again, on the same treatment strip, we have different soil types. So that was a kind of a challenge when I started my PhD, because on my master I had like small plots, everything controlled, so I could take samples. And what about those fields? What should we do? Where to sample, right? So we came up with a strategy. We still don't know if it's the best one, but that's how we try to approach this. It's like we selected 2 to 4 soil types, and those soil types represented in more than 50% of the entire area. And like I said, we are comparing 3 different management systems: the conventional no cover crop, the ones that I'm calling soil health management with cover crop, and this third one here, that is the reference, or the reference condition nearby the field of the producer. So these are just some preliminary data, but like was mentioned before, we have those different properties that we are looking at. And in our case, there are 2 main factors that we are observing here, right? One is the management, that we are the treatments on the cover crop, the no cover crop, and the reference condition. And we have the soil type that we know there was a factor on our field. So we sample by soil type to make sure we are controlling that variable too. And then we have the interaction between management and soil type. So like Nathan mentioned, don't be scared about statistics, but the p-value is something that we can look at to see if there was the effect that we are observing is due to the treatment or is by random chance. So we use the cutoff of 0.1. So I'm going to select here all those p-values that was below that threshold, and which means that for all those properties here, we have this effect of management, but we also have a soil effect on that, and for some properties, we have the interaction. And when we look at all those 4 fields, we see, like, in general, when we look at the chemical properties, the soil has a strong effect on those, the measurements we are seeing. So there are still attempts to how we measure our soil health, and we try to come with a score. Some of you have heard about the Haney Test. So it's quite complicated when we try to interpret those values, because we are comparing sometimes different things. So for example, for the Haney Test, those are the 3 parameters they use to come up with a score. So they use the CO2 respiration, which Dr. Dreiber already mentioned, like there's many factors affecting the CO2. And also, they use 2 chemical parameters, which is like the organic carbon and organic nitrogen. So we should be careful when we are looking at those soil health scores, and I'm going to show you why. For example, if we look at Colfax County, we see that for nitrate, those are the values for conventional, the soil health, and the reference. So if we get a Haney Test, a soil health score, probably the reference will have like a high score, and would make sense, right? We have a native vegetation here, we have a high score. But that's not always what happened, because if you look at this, for example, the reference, there was like no difference in terms of nitrate for those 3 different treatments, which means that when we get the soil health score, probably we would have no difference in terms of soil score among these different treatments here. So what I want to point out here is we should be careful when we are comparing and making comparisons, and also looking at the soil health score, because in this case for the Haney test we have just 3 parameters that are being considered, and 2 of them are chemical parameters. And when we look at the previous table, we see that there's a lot of soil effect on those chemical parameters. So when we talk about those different soil properties, they are all, they have, for example, we are talking about infiltration. It's not, infiltration is related to a lot of other soil properties, right? So what we can do, we can have some more sophisticated statistical analysis to see how those different properties hang together, they are correlated, and also how our observations hang together. So for this graph here, what I want to point out, we have the reference condition here, and we can see that what are the variables that are most related to being classified as reference condition. In our case here, we have enzyme activity, organic matter, nitrate, and aggregate stability, which is the mean weight diameter here that stands for this MDW. So we can also look at the soil health treatment, which is the one with cover crop. And we can see that infiltration rate was highly related to soil being considered soil health, which is in our case, we are comparing those treatments with cover crops. Another thing is like the size of all these errors of these different soil properties. The size gives us an indication of also the importance of each of those soil properties. So if you look at the size, we can definitely see that infiltration and enzyme activity has a long error here, which means those properties are important when we are classifying these 3 different management practices. And this is in agreement with some data already published. So this is from paper published 2 years ago, and they look at the effect of different management practices affected by cover crops. So 1 year of cover crop, we have infiltration rates here as being an important property. Something we did not talk about, aggregate stability, which is a property that is very important. Enzyme activity, like I showed in the previous slide. And when we look at 2 or 3 years after cover crop, again, we still see the infiltration. Yeah, so this is just to show you that there are some data already published where they look at, in this case, this paper looked not only at cover crop, but also the effect of no-till. Since we talk about infiltration rate, I want to go a little bit deeper on this part. So for those 4 fields that we selected, again, here is the different soil types that we collected from the same field. And here is the native condition or the naturalized condition that I mentioned. So we see a trend of increase in water infiltration. And we see that the areas with cover crop is in the middle, so we are going to that transition of like high infiltration rates. And the different soil types that we collected this data from each field. And I want to point out that even though those fields, they were testing cover crop and no cover crop, they had different history of tillage. So in this case, for Greeley County, we have 10 years of no-till, Colfax over 20 years of no-till, like Brandon mentioned. And when we look at the other 2 fields, pay attention on the vertical axis here, the difference compared to this one. So it's lower. And this is because of one of the effects we hypothesize is the tillage being affected here. So again, we see this trend of increase with the cover crop use. And another thing you might ask me, what is going on this field here? Well, when we went to this field to collect data, it was like right after a rainfall, the soil was already saturated and we could not observe like any trend that we were expecting. So that's something we keep in mind, that the initial soil moisture also affects your infiltration rates. So a couple of take-home messages for this part of the presentation. Physical and biological soil properties are sometimes overlooked in assessments of soil health. The soil type should definitely be taken into account when we comparing these different management practices in the same demonstration field. The soil health test should be calibrated to better differentiate among the soil management effects. In terms of the infiltration data, we see that the initial soil moisture affected the water infiltration and should also be taken into account when considering these different sites. And average across different soil types and sites, when we use cover crop, we increase our initial soil water infiltration by approximately 60% compared to the conventional farming systems, in our case, the no cover crop. And the long-term benefits of cover crop and soil health management systems are more evident under reduced soil disturbance, in our case, no tillage, as we could see with the infiltration data. Now, I want to touch base on a second kind of project or data that we have been analyzing. And this is more focused on comparisons of soil health assessments between different transitions to soil health management systems in Nebraska. So when this project was set up, there were two soil health assessments that was being conducted in those fields. One is the Haney Test that most of you might be familiar. And the second one is a protocol that NRCS have that Aaron already mentioned a lot of these different scores that is presented in the book too. So those are the two main assessments that was conducted in those fields. So one of the challenges was like, how can we compare all those different fields, right? So that's what I'm gonna show you here in this part of the presentation. So those were the fields we included in this analysis because they have the two assessments, the NRCS protocol and the Haney Test. And like Andrea mentioned at the beginning, and I wanna show to you this animation here that Andrea and her colleague worked together. We're looking at infiltration, how different alternative management practices affect infiltration rate. So we have producers testing cover crop, integrated livestock, crop rotation because they are interested in maximizing biodiversity. We have minimizing soil disturbance and maximizing soil cover with the use of cover crops. So the question was, how can we combine all those fields together? What we did here, we tried to work on this matrix score. So you will look at here all the fields that we analyzed this data. And we tried to give scores to those fields based on the different management practices that they were using. So we gave a score of either 0 or 1. So 0 means all those scores that are not intended to improve soil health, and 1 are those managements that are intended to improve soil health. So for example, the tillage, we gave scores of 1 for all those fields that had no tillage because they are intended to improve soil health. And we did the same for cover crop, the grazing, manure, and then we came up with this composite rank here, which is basically the sum of all these different management practices intended to promote soil health. So we came up with this composite rank, and if you can see, it goes from 0 to 7. And then we said, okay, higher than 4 are those fields that are soil health management systems. That's how we call them. And then lower than 4 are those considered the conventional practice. So what we have doing so far is looking at all these different, the NRCS soil health assessment and the Haney Test to look at what the things that we are observing. So here, I'm running out of time, right?
You're okay.
Okay. So I'll go pretty quickly here, but this is like the data that was collected at year 1 of this experiment. So I don't want you to look specifically at the raw values here, but what I want to point your attention here, we have been seeing difference between the conventional and the soil health management systems. And this is not only due to the treatment effect, but there is also a history of the field associated with that, right? We have management practices that was doing before the program started. So all this field history plays a role when we are talking about the soil health assessment. And the same for the Haney Test. So some take-home message here. Most of the chemical and biological soil indicators integrated into the Haney Test were statistically different between the conventional and the soil health management systems. Both assessments, they found higher scores or values for the soil health management systems compared to the conventional. But like I said, these results are still preliminary data, but it already shows us that the effects of the legacy and the history of the management. The social aspect that I mentioned about this project, I'm so excited to working with you producers, with the NRCS. So I just want to thank you everybody for being part of this. And last year we have our first gathering together with this group. It was great. Most of them reported a really good feedback, what they have been learning, the interactions. So I'm so excited to be part of it. And I don't know if I have time for a question, but
sure.
Yeah, but thank you so much for your time.